Hello friends, this is my new channel that is Maths Aroma. In this channel, I'm going to share the videos related with mathematics and that are surely going to help you a lot in making the calculation easy and many other topics I'll discuss with you. So in this particular video, I'm going to discuss some rules related to divisibility. You have studied divisibility at many levels, like in class 4, like in class 5, and you studied the divisibility by 2, by 3, by 4, 6, 8, as well as many other numbers. In this video, I'll discuss with you the divisibility by 7, 13, 17, 19, and so on. These are the prime numbers greater than 5. These cases are very special cases and rarely available in the books. Okay, so I am going to discuss these numbers with you, and on the basis of that you can solve other numbers also. So let's start. As I said that these are the unique cases of divisibility. To understand the method related to them, we are going to focus on two things. The first is one more oscillator and the second one is negative oscillator. So if you want to understand this method, one should be familiar with these two words, that is the one more oscillator and the negative oscillator. So first of all, I'll explain you that what is the meaning of these two words. So just pay attention. The first is one more oscillator. So what is the meaning of one more? One more means ek zyada. So one more oscillator means needs one more to be a multiple of 10. Okay, so needs one more. Okay, for example, suppose if we consider the case of number 13. So in case of 13, we will look for a multiple of 13 that needs 1 to be a multiple of 10. Like we know that 13 ones are 13, 13 twos are 26, 13 threes are 39. And you know, if we add 1 in 39, it will become a multiple of 10. So we are going to focus on 13 into 3. That gives us 39. Okay. So now as we have 39, so this is the important number for us. Now 39 plus 1, 39 plus 1, that gives us 40, and 40 can be written as multiple of 10, that is 4 into 10. So this gives us the oscillator, that is oscillator for case of 13 is 4. So how are we going to solve for the oscillator? That is, first of all, we are going to find out the multiple of that number, so that if we add 1 more to it, it gives us a multiple of 10. So we are going to see that what sort of multiple we are going to get. Like if we are getting 20, then it is 2 into 20. 30, then 3 into 30. So in this case we got 40. So it is 4 into 10. So in 4 into 10, we will get the oscillator, that is 4. If 2 into 10, then oscillator 2. 3 into 10, then oscillator 3. So in this case, our oscillator is 4. Okay. So this is one more oscillator. Like second example also we can consider, that is, if you see this example, this is in case of 19. As you know, in case of 19, 19 ones are in itself gives us 19. If we add 1 to it, then it will give us 20. And 20 is multiple of 10, that is 2 into 10. So oscillator will become 2. So that is very easy to find out. Now for the negative oscillator, means the number should be reduced by 1 to be a multiple of 10. Okay. So for example, in case of 7, if you see 7 ones are 7, 7 twos are 14, 7 threes are 21. 21 is a number, if we subtract 1, then we will get 20 after subtracting 1 from 21. So 20 is a multiple of 10. So in this case, what will happen? 7 into 3, that is 21, that is the required result. So 21 minus 1 will give us a multiple of 10, that is 2 into 10. So now the oscillator is 2, but this oscillator is called the negative oscillator. Negative oscillator is the one, it means we reduce the number by 1 to get a multiple of 10, and in one more we add number 1 to get the multiple of 10. This is the difference. Now we are going to see that how are we going to use this to use the rule of divisibility by 7, 13 and like that. Okay, so let's see. It's very easy, and once you will practice it, you will find it very easy. So first of all, I have taken the example divisibility by 7. Is 126 divisible by 7? So what is the rule? First of all, as you know that oscillator, right now we discussed, in case of 7 the oscillator is negative oscillator of 2. So how to solve for the negative oscillator? Okay, so first of all you are going to write number 1 to 6. Now you separate the last digit from this number. Okay, in whichever number you are getting, you have to separate the last digit, that is 6. Okay, so now what is left with us? 12. So we are going to write like this, because we are going to write subtraction 12 minus. Why? Because it is negative oscillator. Okay, this is the use of negative oscillator. So 12 minus the last digit was 6 and oscillator value is 2. So we are going to multiply by 2. Is it clear? So this is 12 minus 12 and the result will become 0. 0 is a multiple, 0 is divisible by 7, therefore 1 to 6 is also divisible by 7. This is the very simple method. Second example, I have picked 2961. In this case the last digit is 1. Okay, so 1, so 296 will be left with us. So 296 minus, what will happen? 1 is the last digit and now the oscillator value is 2. As it is negative oscillator, that's why we are subtracting. So 296 minus 2 will give us 294. Still the number is big. So for 294, what we are going to do? The last digit is now 4. Okay, so we are going to write 29 minus 4 into 2. So this gives us 29 minus 8, that is 21. And you know very well 21 is divisible by 7. Therefore 2961 is also divisible by 7. The method is very simple, but one needs to practice is enough. Okay, so now you see that how is it going to help us to find out the divisibility by 13. Just look at it. In case of divisibility by 13, the example I have picked 273. The method is almost same. For 13, as you have seen, the oscillator that I have already calculated for you, that is 4, because you know very well 13 3s are 39, and that is one more oscillator. 39 plus 1, that was 40, and 40 is a multiple of 4. 4 into 10, that's why we got the oscillator, that is 4. Okay, so now as it is one more oscillator means added. Okay, so in this case we are not going to subtract, we are going to add. So how to solve now? 273 can be written as 27 plus 3 into 4. That gives us 27 plus 12, that is 39, and 39 is divisible by 13. Therefore 273 is also divisible by 13. Now the last example, that is 24167 divisible by 13. So how are we going to solve? 24167. Clearly the last digit is 7. So we are going to write 2416 plus 7 into 4, that is 28. So 2416 plus 28 will give us 2444. Now again we are going to repeat the step, that is 2444 means the last digit is 4. Now 244 plus 4 into 4, that gives us 244 plus 16, that is 260, and 260 is clearly divisible by 13. Therefore this number is also divisible by 13. So this method is very easy. On the basis of this method, you can apply it on number 17 as well as 19 and many other prime numbers. If you have any doubt, you can ask me. First of all, try this method at your home and ask your doubt. So likewise, I'm going to share many other methods with you and many other techniques related to maths. So stay tuned with me and good night and stay safely. Thank you so very much.